Hello students, how are you all? I hope everyone fine. So today we will start the new chapter called mathematical induction. So last chapter was the trigonometric, big chapter, important chapter is done. This is a small chapter and easy chapter, and this chapter is exclusively for 5 marks. Okay, yeah, so the topic name is mathematical induction. So observe carefully. I'll give you one concept of mathematics. Maybe first time you're getting this information, or okay, you may heard somewhere else. Okay, yeah, in mathematics there are two types of method. There are two types of method to prove something, or there are two types of problem, you can say. There are two types of problems. The one type of problem can be solved using deductive method. To prove that one set of problem, we are using deductive method. This maybe you learn in our 10th standard or maybe 9th standard, the proof of some mathematical statement which is using deductive method. I'll explain, don't worry. The second method is inductive method. This method you didn't learn anywhere up to now. You don't know about this, because this method you are going to learn in this chapter as a mathematical induction. The deductive method is known as mathematical induction. Okay, now I'll just explain very briefly what I mean by deductive method and which type of problem you are using in deductive method. Say for example, the problem is like this. Is divisible by 2. Statement 1. Okay, next statement 2. Every even number is a multiple of 2. Okay, therefore I can write after this 8 is even number. Using some statement and writing the conclusion is called the deductive method. See, we know 8 is divisible by 2, every even number is a multiple of 2, so 8 is also a multiple of 2, so 8 is even. Okay, this conclusion or this method, using these two, statement 1, statement 2, I can write some conclusion. This type of method is known as deductive method. Not detective method, deductive method. Or maybe problem is like this: x into y is equal to 0 and x is equal to 0 or y is equal to 0. Okay, product of, if you want to prove this, yeah, you can, to prove this you can use this, or to prove this you can use this, one and the same, right? So to prove this type of statement also we are using deductive method, writing some statement and writing the simplification, that is called deductive method. Remember that. Okay, so this type of problem is called deductive method or method problem. But suppose question is like this: 1 plus 2 plus, prove that, equal to n plus n, equal to n into n plus 1 by 2. Suppose you want to prove this. Actually you know this, because maybe in 10th standard you learned sum of first n natural number is equal to n into n plus 1 by 2, but you didn't prove that. But suppose question is prove this statement, then deductive method is not possible to use, because that n can be anything. No, you can't give example, you can't take n is equal to 10 and prove this, no, or you can't take n is equal to 100 and prove this. You have to prove in general, and this result is true for all integer, remember, or natural number, positive integer or natural number. So is it possible to take all the natural number and verify or write the solution for this? Definitely not possible. So this type of problem you cannot prove using the deductive method, the method which you learn in the previous classes. So now we need a new method. Definitely whatever you are going to learn under this heading, it's a completely new method. Okay, you need a new method to prove this. Remember, you need a new method to prove this statement. That method is called mathematical induction. That method is known as mathematical induction. So today we are going to learn what do you mean by mathematical induction, or what do you mean by inductive method. Deductive method already you learned, so ಇಷ್ಟೇ ಇರೋದಿಲ್ಲ ಟೆಕ್ಸ್ಟ್ ಬುಕ್, ಜಾಸ್ತಿ ಇಲ್ಲ deductive method ಮೇಲೆ. Okay, so don't worry. So you are going to learn the new method to prove a new type of problem. Remember, it's a new type of problem. You didn't prove whatever we will get in this chapter. Okay, it's a new type of problem and new method you're going to learn under this heading, mathematical induction. So very simple small chapter, remember, and this is as I told, exclusively for 5 marks, 1 mark, 2 mark, 3 marks. Okay, so let me explain now what I mean by inductive method. Okay, the inductive method ಅಲ್ಲಿ ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡ್ತೇವೆ ಹೇಳಿದ್ರೆ, see for example this statement. First you have to check the statement is true or false. Okay, put n is equal to 1 and check. You have to check, okay, whether the given statement is true or false, because suppose this question is given like this and you are asked to prove this. You 1 hour ಬೇಕಾದ್ರೆ try ಮಾಡಿ, 3 hours ಬೇಕಾದ್ರೆ try ಮಾಡಿ, you will not get the answer. You can't prove this because this statement is a wrong statement. Suppose if you not verify whether the given problem is right or wrong, and if you started to solve, suppose question is wrong, then you are going to waste time. Okay, that should not happen. See, suppose here n minus 1, put n equal to 1. The first term LHS is equal to 1. LHS is equal to 1. What is RHS? On the right hand side, 1 into 1 minus 1 by 2. So this is 0. At the first level only, or the first step only, you will come to know that question is wrong. Then you can write, yeah, this question is wrong, I cannot prove this. Okay, suppose if we not verify this in this type, especially in this type of problem, in inductive problem, first step is always to verify whether the question is right or wrong. Sometimes by mistake or by print mistake question is wrong and you are simply wasting time. That should not happen. So in all the inductive method, you are going to verify whether the question is right or wrong. See, now I can compare this whole process to a concept called dominance. ನೀವು ಕೇಳಿರ್ಬೋದು ಅಲ್ವಾ, ಒನ್ ಟೈಲ್ಸ್ ಅನ್ನ ದುಡ್ತೇವೆ ಆಗೆಲ್ಲ ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬೀಳತ್ತೆ, ರೈಟ್? ಡಾಮಿನಸ್ ಅಂತ ಕೇಳಿದಾರಲ್ವಾ. ಓಕೆ, ಸೊ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ನೌ what do you mean by principle of mathematical induction, or what is a procedure involved in mathematical induction using one concept called dominance. You know about it. Okay, we will arrange here the same size tiles, okay, in a row or in a column or in a circular pattern, and we will push the first tile and it will fall on the second tile, and second tile fall on the third tile, and so on, right? And maybe you saw all the tiles will fall, or maybe playing cards, so many things we can arrange. Okay, this concept is called dominance. Okay, so we will keep those such dominants. Okay, so one tiles na push ಮಾಡ್ತೇನೆ. Suppose the first pushed tile does not falls on the second one. Now whether after that remaining tiles will fall? Definitely no. Andre first step is wrong. Here compare, just now I told you in inductive method problem you have to verify the question is right or wrong. So maybe some by mistake or purposely they make you, the teacher can give the wrong question and you are asked to prove, and you are writing so many things and at the end you are not getting the answer. So first step is always you have to verify, okay, whether your arrangement is proper, whether the given problem is proper. Suppose first tile is second tile ಮೇಲೆ ಬೀಳಲಿಲ್ಲ ಅಂತಂದ್ರೆ, how the remaining tiles will fall? Definitely not possible. You are not pushing everything, you are just pushing the first tile. Remember, you are just pushing the first tile. Suppose the gap between the first tile and the second tile is large, and so that if first tile does not fall on the second tile, the whole process is gone. Okay, now let us assume that the arrangement is proper. The first tile is falling on the second tile, and second tile definitely the falls on the third tiles, and so on. And that process start ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿ. Suppose ಇಲ್ಲಿ question correct ಆಗಿದ್ರೆ, you will come to know that, see this 1 by 2 by 2 ಏನಾಗುತ್ತೆ ಆನ್ಸರು 1. ಅಂದ್ರೆ question confirm, question correct ಇದೆ confirm ಅಲ್ವಾ? So now definitely you can prove it. Definitely the proof is exist. So that if the first tile falls on the second tile, you can assume that the arrangement is proper. Okay, but we don't know, okay, whether the arrangement is proper from first to end, the first step to the last step, or the first tiles to the last tiles. We don't know, so we have to check now that method. Okay, to checking whether all the tiles are kept in the proper form, the method is known as principle of mathematical induction. What it is, okay, what it tells, the principle of the mathematical induction. Observe carefully. If the first tile falls on second tile, then you are going to assume that, okay, given question is proper, so definitely you can continue. Now after that you are going to check whether second tile falls on third tile falls on fourth, like that, fourth on fifth, and so on. At one level, at the one stage, you are going to assume that 50 tiles are there. In between you are going to check whether 100th tiles it falls on 101. ಅರ್ಥ ಆಯ್ತಾ? ಫಸ್ಟ್ ಅದು ಬಿದ್ದಾಗಿದೆ, ನಮ್ಗೆ ಚೆಕ್ ಮಾಡಿ ಆಗಿದೆ. ಸೊ ಅದೇ ತರ ಯು ವೆರಿಫೈಡ್ ದಟ್ ಸೆಕೆಂಡ್ ಫಾಲ್ಸ್ ಆನ್ ಥರ್ಡ್ ಫಾಲ್ಸ್ ಆನ್ ಫೋರ್ತ್. ಓಕೆ, ಅದೇ ಕಂಟಿನ್ಯೂ ಆಗ್ತದೆ, ಎಲ್ಲ ಚೆಕ್ ಮಾಡೋದಿಲ್ಲ ನೀವು. in between you will verify, you will verify whether 100th tiles will fall on the 101th tiles. Suppose it is falling on the 101 tile, then once again you will continue, you will not check one by one, you will verify 130th tiles or falls on 131st. So in between you are going to check. In between you are going to check. So ella in between alli nim check ಮಾಡಿದಾಗ satisfy ಆಗ್ತಾ ಬಂದ್ರೆ if everything is proper in between, then you are going to check the last but one tiles whether it falls on the last. If the last but one tiles falls on the last tile, then what we can write the conclusion, the arrangement is perfect, all the tiles on the ground. This is a concept. I'll explain this mathematically or in the mathematical induction way now under the heading principle of mathematical induction. Illi just check maadu, first ondsal check ಮಾಡ್ತೀರಿ, middle ondsal check ಮಾಡ್ತೀರಿ, ಸ್ವಲ್ಪ ಹೊತ್ತು ನಂತರ ಇನ್ನೊಂದ್ಸಲ ಚೆಕ್ ಮಾಡ್ತೀರಿ, ಅದೇ ತರ in between you are going to check, and at the end you are going to check whether the last but one tiles falls on the last one. So ಅದೇ ತರ ಎಲ್ಲ middle check ಮಾಡಿದಾಗ if everything is proper, we write that everything is proper, the proof is over. So the same logic I'm using, okay, mathematically I'll explain that, okay, in terms of one paragraph. Observe carefully. Again logic use ಹೇಳಿದೆ dominus ಅಲ್ಲಿ ಅದೇ logic ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇರೋದು. Okay, observe carefully. Suppose there is a given statement P of n. ಇದು problem tiles, the arrangement of tiles involving the natural number. The count, see, n should be the number of elements, number of object, number of numbers should be a natural number, remember that. So this is important, okay, involving natural number n, this is very important. Okay, so here important thing is natural number n, the count should be a natural number. Suppose n is not natural number, then you cannot use a principle of mathematical induction. Okay, suppose given statement is P of n and involved number is a natural number such that these conditions satisfy. See, in first statement, the statement is true for n is equal to 1. Statement is true for n equal to 1. Already I explained this. First you have to check whether the given statement is true or not. First you have to check whether the first tile falls on the second tile, because first tile does not fall on the second tiles, definitely the remaining process is not possible. Just like that, you have to verify. The first step in the mathematical induction is verify the given statement is true or false. Put n equal to 1 on both ends and check whether it is true or false. Okay, suppose first one is true, then proceed the second step. In second step, if the statement 1 is true, then assume the statement is true for n is equal to k. First tiles falls on second time, second, third, fourth, fifth. So you are not going to continue that process. You are going to check in between whether 100th tiles is falling on 101. Okay, one by one check ಮಾಡ್ತಾ ಇದ್ರೆ impossible. Suppose 100, 150, okay, fine. Some dominos you may saw, there are so many big number of tiles, big number of playing cards. So ಎಲ್ಲಾನು check ಒಂದೊಂದೇ check ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. Okay, so you cannot verify each and everything. So in the beginning you will verify few, and in between you will verify. Okay, so like that only the second work is to verify in between whether it working or not. So we assume that the result is true for some k. Result is true for some k. If I compare to the previous dominant, okay, we check whether 100th tiles is falls on 101. Suppose it is true, then we proceed. If not, we will keep it proper. So adhe tara we assume that result is true for n is equal to k. Now using this assumption, the third step is you are going to prove that if it is true for k, then you are going to prove that it is true for k plus 1 also. And the immediate next. If compare madre, suppose 100th tiles is falling on 101st, then you are going to prove that 101st is also falling on 102nd, and mat puna ellanu check madala, in between you are going to verify. So first step check whether the given statement is true or false. What is second work? Assume the result is true for n is equal to k. The third step is using that assumption prove that it is not only true for n is equal to k, it is also true for k plus 1 also. It is also true for k plus 1. So once it is over, in proof 100th tiles, you saw 100th tiles is falling on 101st, and also you verify the 101st tiles is falling on 102nd. ಅರ್ಥ ಆಯ್ತಾ? Suppose 102, 102nd tiles is falling on 103, then you will prove 103rd is falling on 104. So ಅದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So ಇಲ್ಲೆಲ್ಲನೂ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. So in general I took that 100, okay, it's a fixed number, but I am taking some unknown, that is k. Okay, so I'll repeat. First end ಮಾಡಬೇಕು, write the given problem as a p of n, then verify the given problem for n is equal to 1, then assume if it is true for n equal to 1, assume that it is true for k also, and using that assumption you prove that it is true for k plus 1. That's it. So this is the procedure. If it is true for k plus 1, then you can write the conclusion that it is true everywhere, or it is true for all natural number. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? So this is a procedure of principle of mathematical induction. Directly you can connect this concept to the dominus. Understood? Very good. Now I'll explain this concept, okay, with one example. One problem ತಗೊಂಡಿನ ಅದನ್ನ okay ಇದೇ problem ಮತ್ತೊಮ್ಮೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ explain ಮಾಡ್ತಾನೆ using the principle of mathematical induction. Then you can solve along with me, okay? Yes. I'll take one problem now to explain what I mean by principle of mathematical induction. What is the problem? Exam ಹೀಗೆ ಕೇಳ್ತಾರೆ 5 marks ಗೆ, prove by mathematical induction that 1 plus 2 plus 3 plus 1 up to n is equal to n into n plus 1 by 2. You know this result, you already learned in 10th standard that sum of all first natural number is equal to n into n plus 1 by 2. Now I am going to give its proof, and this proof is using inductive method, okay? Inductive method, as I told, is okay, it has some different procedure which you not applied up to now, okay? I am going to show you now how to apply the method which I explained in the okay previous concept. Yes, so proof is as follows. First, take the given statement as a p of n. 1 plus 2 plus so on up to n is equal to n into n plus 1 by 2. Okay, you take the given problem as p of n. Then you're going to verify that result is true for 1 or not. Put n is equal to 1. Left hand side and n equal to 1 and the ill baratte. So left hand side will be 1. Then put n is equal to 1 in RHS, that is 1 into 2 by 2, and it is equal to 1 because 2 get cancelled. Yeah, so what is the conclusion? P of 1 is true. Second step, you know, you assume P of k is true. That is which is true? P of k andre no, idu P of n adre, if this is a P of n, what is P of k? 1 plus 2 plus so on up to k is equal to k into k plus 1 by 2. K into k plus 1 by 2. Okay, you name this as a 1. You name this as 1. Yes. So now we have to prove. In prove madbeku. If you assume that P of k is true, you have to prove that P of k plus 1 is also true. So you have to prove P of k. Using this assumption, you have to prove that P of k plus 1 is also true. You have to. This means you are using that P of k is true, and you are proving P of k plus 1 is also true. So to prove this, okay, observe carefully or remember this step always. Add the next term of k. What is add the next term of k? See, what is the next term of 1? 2. What is the next term of 2? 3. What is the next term of 3? 4. And one more than the previous. So which is the next term here? Next term of k is, you know, k plus 1 to both sides. You add k plus 1 to, this is a procedure to prove, okay, that P of k plus 1 is also true to both sides. So both side of, you know, 1 b bar is andre both side nen pirli. Now both side you should add. First add to left hand side, but 1 plus 2 plus so on up to k, and next term k plus 1, correct? Right hand side ಏನಾಗುತ್ತೆ? k into k plus 1 by 2 plus k plus 1, correct? ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? ಸೊ ಇದೆರಡು ಟರ್ಮ್ ಅಲ್ಲಿ ಏನ್ ಕಾಮನ್ ಇದೆ? ಯಾ k plus 1 is common. Take it outside. ಏನ್ ಬರುತ್ತೆ? ಯಾ k plus 1 ಹೊರಗೆ ಬರುತ್ತೆ. Only remaining is k by 2 plus 1 ಅಲ್ವಾ? k by 2 plus 1. So ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ? k plus 1, take LCM, it become k plus 2 ಅಲ್ವಾ, divided by 2. Okay, now observe carefully. We completed already. See, if this is P of k, what is P of k plus 1? If this is P of k, what is P of k plus 1? K idalli k plus 1 ಹಾಕಬೇಕಲ್ವಾ? So 1 plus 2 plus 3 plus k, next k plus 1. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? So P of 1 ಅಂದ್ರೆ ಏನು? 1 ಅಲ್ವಾ? P of 2 ಅಂದ್ರೆ 1 plus 2. P of 3 ಅಂದ್ರೆ 1 plus 2 plus 3. ಅದೇ ತರ P of k ಇಲ್ಲಿದೆ ನೋಡಿ. So what is P of k plus 1? 1 plus 2 plus 3 plus k dot 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 plus k plus k plus 1. On the left hand side banda. If this is the expression for P of k, what is the P of k plus 1? If this is for P of k, what is the expression for P of k plus 1 ಹೇಳ್ತೀರಾ? P of k ಇದ್ದಾಗ k ಬರಬೇಕು. P of k plus 1 ಇದ್ದಾಗ ಏನು? Instead of k you have to get k plus 1. Tell me ಏನು ಬರುತ್ತೆ? If this is P of k, what is P of k plus 1? Replace all k by k plus 1. Check ಮಾಡಿ ಏನು ಬರುತ್ತೆ ಹೇಳಿ. So what is this actually? K plus 1 into k plus 2 by 2. ಕರೆಕ್ಟಾ? ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಮ್ಯಾಚ್ ಆಗಿದೆ, ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಮ್ಯಾಚ್ ಆಯ್ತು. ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರಾ? ದಿಸ್ ಇಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಆಫ್ ಪಿ ಆಫ್ ಕೆ ಪ್ಲಸ್ ಒನ್, ದಿಸ್ ಇಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಆಫ್ ಪಿ ಆಫ್ ಕೆ ಪ್ಲಸ್ ಒನ್, ಅಂಡ್ ವಾಟ್ ವಿ ಪ್ರೂವ್ಡ್, ದೇ ಆರ್ ಈಕ್ವಲ್. ಸೊ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಇಸ್ ಈಕ್ವಲ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಂದ್ರೆ ಏನು? ಪ್ರೂಫ್ ಇಸ್ ಕಂಪ್ಲೀಟೆಡ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ವಿಚ್ is P of k plus 1, which is P of k plus 1. Therefore, what is the conclusion? If this is true, if you prove like this, then you can write, therefore P of n is true for all n belongs to n by mathematical induction. Done. Ishte problem, ishte irodu 5 marks keltene please. This problem you will get for 5 marks. I hope you understood. Enella procedure ittu, take the given problem as P of n, verify the result for n is equal to 1, then you assume result for n is equal to k, then prove that, okay, using the assumption that result is true for P of k plus 1. So next step very simple. So a proof, I hope you understand. Second question for today's class, 1 cube plus 2 cube plus 3 cube so on up to n cube is equal to n square into n plus 1 whole square by 4. This is another result. Sum of cube of first n natural number is n square into n plus 1 whole square by 4, and question will be always like that, proved by mathematical induction. Okay, so what is the procedure? Take the given statement as P of n alva. So P of n in barate 1 cube plus 2 cube so on up to n cube equal to n square into n plus 1 whole square divided by 4. This is a given statement. Now you have to verify this result is true for 1 or not. Put n is equal to 1. LHS the first term 1 cube equal to 1. So what is RHS? We'll substitute 1 plus 1 whole square and 2 square by 4. Again it will be 1. So LHS equal to RHS. Therefore LHS is equal to RHS. So P of 1 is P of 1 is 2. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? So we verified that given problem is proper. Now using this verification you are going to write the assumption. What is the assumption? Assume that P of k is true. Assume that P of k is true. What do you mean by P of k? Yeah, P of k is equal to 1 plus 1 cube plus 2 cubes on up to k cube is equal to k square into k plus 1 whole square divided by 4. So 1 cube plus 2 cubes on up to k cube is equal to k square into k plus 1 whole square by 4. Take this as a 1. Now using this assumption you have to prove that it is also true for k plus 1. So so write like this, to prove P of k implies P of k plus 1. So you have to prove now the result is true for P of k plus 1 using the assumption that P of k is also true. Okay, fine. Now observe carefully. What is P of k plus 1? You can do one thing here. Suppose you find difficult to decide what is the next term you have to add, write the P of k plus 1 in the beginning. Actually this is not required, but for your convenience you write P of k plus 1. 1 cube plus 2 cube so on up to k cube the next term ಏನಾಗುತ್ತೆ ಹೇಳಿ? Yes, k plus 1 whole cube equal to ಇಲ್ಲೇನು k plus 1 whole, wherever you k is present replace it by k plus 1. Remember this you have to use, this you have to prove, don't use it. This you have to prove, remember, don't use it. Compare ಮಾಡಿ ಏನು missing ಈ statement ಅಲ್ಲಿ? This term is missing. So what we should do? We should add this term to both sides. Add k plus 1 whole cube to both sides. Add k plus 1 whole cube to both sides. Fine. Now when you add this to both sides, okay, of which one? 1. Remember you have to add this one to both side of 1. So 1 ಏನಿದೆ? ಈ expression. So in left hand side 1 cube, 2 cube so on up to. So add k plus 1 whole cube to both side of 1. The left hand side will be 1 cube, 2 cube so on up to k cube plus k plus 1 whole cube. Correct? Right hand side of 1. Remember ಇದಕ್ಕೆ add ಮಾಡಬೇಡಿ. So k square into k plus 1 whole square by 4 plus k plus 1 whole cube. So now you have to simplify this. ಹೇಗೆ simplify ಮಾಡೋದು? Take the common term outside. Which is the common term? K plus 1 whole square is common. So what you will get? K square by 4 plus k plus 1. So that is k plus 1 whole square. When you take LCM, it will be k square plus 4k plus 4 by 4. And this is nothing but k plus 1 whole square. This is nothing but k plus 2 whole square. You can check what is k plus 2 whole square. K square plus 4k plus 4 divided by 4. So you see, you know this answer. You wrote this answer in the beginning. K plus 1 whole square, k plus 2 whole square by 4. So this is nothing but p of m plus 1, which is p of m plus 1, which is p of m plus 1, k plus 1. So what we proved? You proved that p of k plus 1 is also true for all k, or using the assumption p of k. So then, by according to principle of mathematical induction, therefore p of n is true, is true for all n belongs to n by mathematical induction. This complete. One more 5-mark question. So still so many problems are there, around 15 problems are there, just 2 problems are over. I hope you understood. If you have any doubt regarding this simplification, don't worry, that doubt will be clear in the next problems. Okay, very good, thank you.